warm welcome to TecKXpert 15th webinar. Welcome all members, and we are very glad to see all of you join us today here for the webinar on the topic of problem identification methodologies in utility equipments with case studies, and it's given by none other than Mr. Ashok sir. Thanks a lot for that. TecKXpert was founded with a vision to organize the world's technology experts onto a single network to enable sharing of knowledge. And with this single vision, Murugesan sir had founded this group way back in 2013. And with over 6,500, close to almost 7,000 strong members across several locations, TecKXpert is working hard towards knowledge transfer and knowledge exchange from a lot of its members. So with this vision, today we have an agenda especially on the topic of problem identification methodologies in utility equipment with case studies. But however, we will start with a welcome note by our founder, and followed by this webinar, the main topic, followed by the question and answer session, vote of thanks, and the feedback poll. And with this, I would request our founder Murugesan sir to give a small welcome note for our members here in the event. Thank you, Murugesan sir.
Hello everyone. Good evening.
Good evening.
I feel immensely happy to welcome you all in this wonderful evening to 15th edition of TecKXpert's Masterclass session. Today's topic is problem identification methodologies in utility equipments. We are planning this topic as a series of webinars, Masterclass sessions, as this is a very vast subject. That way, we are here with today Mr. Ashok Seduraman sir, a BEE accredited auditor and very eminent author of various technical articles in various magazines, who has done more than hundreds of audits in various industries for the past 2 decades. With his vast experience, we strongly believe that he is the very apted person to handle this subject. Even though today he will concentrate in many utility equipments, he will more talk about compressors, that is industrial as well as chiller compressors. In coming weeks, we will concentrate other utility equipments also, one by one. Thank you to Mr. Ashok Seduraman sir for accepting our invitation for presentation.
Thank you.
It's a very good, great opportunity for us to learn from your vast experience. I request all of the participants to come out with more questions on the related subject and make use of this wonderful opportunity to its maximum level. Kindly download your learnings, whatever you are taking from here, to your down the line team also at your workplace. Thank you all. With this, I request Mr. Shravan to take over further. Shravan, over to you.
Thank you, sir. Thanks for these inspiring words, and we aim to do many more such sessions in the near future to come. With this, I move on to the main agenda for today's webinar, and I am really excited to introduce our keynote speaker, Ashok sir. And he's a well-known figure in the energy efficiency industry in our country's energy efficiency journey. And to briefly introduce, Ashok sir is a BE empaneled and accredited energy auditor. And he is also the vice president of Indian Association of Energy Management Professionals. And he has conducted over 400 energy audits in industries across India and abroad as well. And with 4 decades of vast field experience in industry maintenance projects and commissioning, he is currently helping in energy efficiency journey of the country. And he had professional training in India and abroad as well. And he has also, like Murugesan sir said, written a lot of technical articles in national and technical magazines. So with this, I would request Ashok sir to take us through the topic today, the main keynote presentation. Thank you, Ashok sir. It is all yours.
Thank you, sir. Thank you, Murugesan sir and Shravan Gupta ji. Thank you for giving the excellent opening. Thank you. Coming to this problem identification methodology in utility equipments. Next, please. I'll just read. Okay. So the main idea is the origin of inefficiencies creeps into the utility machines right from the wrong installation and silently ignored now by the industry, where all the areas where the problems can be identified and methodologies how to spot the same and how to correct the same economically at the post-COVID time. This is what we are mainly looking at it now as such. So as our Murugesan sir said, it is going to be a series of webinars starting from our TecKXperts and all the utility equipments, right from transformer to electrical distribution to compressors, pumps, fans and blowers, boilers, steam distribution, HVAC and refrigeration. These are all the areas where the utility can be tuned, fine-tuned or optimized to have a excellent production at the same time energy savings also, which is optimized and we can achieve more as such. So let us start with what is the type of maintenance the industry is as such actually operating now. Many of the industries have changed over from the corrective or the breakdown maintenance to preventive maintenance to predictive maintenance to precision maintenance. What all we have been using as per the to attend to the breakdown jobs, now we have gone for preventive maintenance with all the predictive monitoring equipments like infrared sensor, infrared thermal imagers, ultrasonic leak detectors, and all the oil analysis and the vibration analysis. Lot of more aspects we are talking now, and we are as such planning in the industry to see to it that the industry is able to cope up with what all the machine is able to predict or operate or giving the prompting. This one, this can be sensed correctly and this can be monitored. So condition based monitoring plus predictive plus preventive maintenance, this is going to be the order of the day in future years to come. Thanks to this IoT and all the industry 4.0, everything is embedded into this. And to start, the base of all these aspects is condition based monitoring. This is where we are going to concentrate now. To start with, on the transformers, let us say we have the transformers in the industries, and then on the, I'm talking about the ST consumer only. Let us see, it's having a mixture of linear and non-linear loads. At the moment, everyone has already burnt their fingers by keeping a unity power factor. Maybe it's a KBH billing or it's a KWH billing. What is the stable power factor to be kept for the given industry for a mixture of loads? It is varying from industry to industry, but you have to choose the optimum power factor and then not the unity power factor at all. See, optimum power factor means every week you just keep it at 0.96, 0.98, next week 0.99. At which power factor your capacitor burden is, capacitors are not burdening you, at the same time your voltages and your electrical distribution is stable and it is stabilizing. This is where the optimum power factor is achieved now. Then on the THD, power quality, what is the THD we are maintaining within the norms at the normal load. If you are using a OLTC in the industry, number of counters the OLT is operating per day, this will decide the functioning of the OLTC, and you can just fine tune the OLTC band in such a way that the tap changeovers are less. At the same time, you are stabilizing the voltage at the downstream for the industry. The metering of the HT side and secondary side will show the daily, weekly, monthly, what is the transformer loss for the given for your industry, and this can be monitored. See, these are all the problems getting identified by condition monitoring, which are all with the in situ measurements, which are all with the portable measurements. So the loss between the ST and the LT, this is varying, and it can be seen for a week, means on the week full days and on the week holidays also, what is the condition of the transformer losses, and this can be assessed and this can be analyzed. Next to this is the electrical distribution side, where the reactors or the capacitors, what all the distribution is there and how much it is there. If it is more of non-linear loads, let us say we have a lot of VFDs in the system, this is supposed to give you a power factor of always around 0.95. That is what the branded VFD OEMs claim as such. For a no load to full load, for a given equipment, for a given loading, the VFD is going to maintain a power factor of 0.95, means that much amount of capacitors can be definitely switched on in the existing power distribution, electrical distribution side, and then try to maintain the power factor between 0.95 and 96. So for the given transformer, the condition monitoring of transformer All the other parameters we are taking care from the maintenance side, on the thermal imaging side, what are all the switching, what are all the contacts, what are all the body of the transformer, what is the PD, the basic insulation levels, everything we are taking over. But the moisture, especially now at the time of COVID crisis, and even in many of the power and distribution transformers, you find the moisture is just increasing into the transformer in microscopic amounts. This is causing a lot of electrical breakdowns. These are all the case studies which we have seen in the industries. Why the breakdown has come when all the transformer subcomponents are fine, still the breakdown is coming, means this can be addressed upon by reduction of the moisture which is increased in the transformer. Say recognition of small and micro amount of this moisture, definitely this is increasing the voltage stress on the transformer, the load, as well as the basic insulation level also it is put to test. More than that, it is not only hazard on the dielectric performance of the oil, but also on the insulations that is immersed in the oil. That is why age-old thinking is we are all going for this heat and vacuum practice of the transformer drying out system. But now the concept has changed to transformer online drying out system, where we use the cellulose type absorptive cartridges within the system, and it will be online, and this will be able to remove the moisture in the transformer, this one, by the circulation of this oil, and removing this moisture. You can see the parameters before and after doing this online dry out system. This is going to be the order of the day in the future years to come. Definitely this is an add-on system to the existing transformer to maintain the quality, the sustainability of the transformer, especially the transformer characteristics. You can see the ppm has come down from 100 to 5, it has come down. Also the dielectric strength has improved to 70 from 30. Also the corrosive sulfur that has become totally non-corrosive. The visible thinking is the opaque brown color of the oil has become clear and light yellowish in color. Gas content also comes down. So this is going to take over, especially on the transformer dry out system. Instead of offline dry out system, online dry out system with this absorptive type cartridges, which will continuously remove the moisture. It will be kept on along with the transformer as an auxiliary, and it will be put to use, and it will remove the moisture from the transformer. I am just, as our Murugesan sir was telling, I am just giving few examples and case studies where the problems are identifiable, or the parameters that is meant for identifying the problems in each and every part of the utility, like from transformers to motors to compressors and other things. So motor loading, basic parameters. See, motor loading is where we stand around, it is less than 50 or around 50 to 75 or 75 to 100 or 100 and above. Where we stand around 60 to 80% is the efficient loading, we all know. But still, the basic parameters like the voltage and current for the given motor, it is definitely a worth thing to monitor to see whether the current unbalance or the voltage unbalance are there. All the inputs, I'll just come in next few slides where we are missing and why this breakdown comes in a given motor due to not fixing the point or fixing the problem with the existing parameters. Excess input kilowatt for the given motor. Why the motor is running hotter now? Especially when the VFD is there on an old motor temperature definitely shoots up by another 6 to 10 degrees. How this can be seen and how this can be taken further action as such. So a thermal image scanner or the infrared thermal imager, definitely it is going to be the, it's a quite invasive, non-invasive tool, and it immediately gives the motor characteristics or the thermal characteristics of the given motor. Apart from the electrical characteristics, what is the input and what is the output, like what is the shaft RPM measurement. This is also our more important to us. Lubrication, we have been used to this multi-purpose grease for all the motors, but the specialty greasing is definitely demanded for all the type of motors. By going for that, we can able to reduce the temperature of the motor by more than 20 to 30 degrees, and ambient plus 20 degrees is the allowable temperature for a normal healthy motor. That's what we want to see now. Then comes the ventilation and why the no load power for the given motor goes up. Let us go by step by step. So to start with the motor loading, where we stand and around 50 to 70%, let us say it's 60 to 80% for a given motor loading, it is more efficient. And what all the things to be identified is which are all the motors having a low voltage or a low power factor, or the voltage unbalance is there, imbalance is there. These are all the areas to be corrected to have the improvement measures in the motors. These are all on the motor side. On the machine side, we will see what is the idling operation or the throttling operation or the damper operations. These are all the areas to be corrected, and any of the dampers which is used in the machine, that has to be corrected to a VFD. Instead of a damper, VFD definitely has a 40% improvement in the energy losses that is there, that can reduce by almost 40% from a damper to a VFD as such. So a thermal imager, when it is used in a motor, not only on the drive side and the non-drive side, normally the temperature should be less than 20 degrees is the deviation between the two sides. It cannot be more than 20 degrees. And if it is on the drive side, we see this 3, 6, 9 and 12 of the clock version. The drive side is one image, non-drive side is one image, top side or the bottom side or the left side or the right side. Almost 4 to 6 images per motor will definitely show whether the motor is healthy running, whether it is a warm and harsh, hot, not a hot motor, and what is the temperature difference that is there in each side. These are all the areas to be corrected, and it is a very simple, effective tool which is used in any type of motors in the industry now. The possible abnormal situations that is coming in the motor and the possible causes. See, the motor overheating happens. Having seen in the thermal imager, the motor is getting overheated. Why? The obstructed ventilation. The ventilation, it should be there. I'll just show in few slides why the ventilation which is getting obstructed is causing the non-driven temperature is going more than the driven temperature, and the motor is suffering more there. Then the smaller size fan, many of the old OEMs or the old motors which had a smaller size fan. In fact, if you see some 20 years back, we have used an aluminum type of blade with a heavy fan, so that if you stand in almost 3 feet, almost 1 meter in front of the motor also, you can see the flow of the static pressure of the fan that is at the back of the motor. So the fan has to give you a better ventilation or a better air throw across the motor fins to remove the heat from the motor, and the heat transfer should be more excellent as such. Then all the motor related problems like rotor trubbing on the shaft or the failed motor or the stator with insufficient impregnation, these are all coming from the OEM side, and what is to be maintained as per the design and what is maintained. If it is on the field load side, the overloading also is cause of overheating and defective bearing. Having gone for a VFD for an existing IE1 motor, which is a standard or a conventional motor, definitely the bearing needs to be changed to as an insulator type bearing. If we have not changed, definitely bearing is the first culprit to go and fail as such. That is going to first fail, and it will have an impact on the motor's running temperature also. It goes more and more by 5 to 10 degrees and more also. So the air gap that is specified by the OEM, is it maintained? If it is single phase motor, means excessive this run capacitor, improper run capacitor also can raise the temperature of the motor. So the motor overheating has almost 10 or 12 number of factors, which are all the areas which is causing the overheating that can be addressed to as such. You see two types of motors. Motor fan cowl is supposed to have this the fan cowl is supposed to facilitate the air passage through the fan to the motor. If the fan cowl is given in such a way that the gauge is kept like this, depending on the industry, depending on the environment, this fan cowl has to be selected. This problem identification tool is one of the problems identified in many of the industries. Is the motor's non-driven is getting hard because there is no air passage at all. This can be corrected by the right. You can see the what is do not and what is the do type of image on the right side. You can see the whatever may be the fluff or the dust that can just pass through it, and definitely the motor is always kept a cooler temperature by the fan, which is effectively run. The fan has to run at the same time, the air has to pass through the fan through the fins, so that it should be mild. At the same time, it should remove the heat. The heat transfer should be there from the fins to be out. All the motor OEMs give excess number of fins, especially in the IE3 motors and above, so that the motor heat is definitely dissipated outside to the ambient surroundings. So if the fan is not functioning on a TFC motor, or the airflow is not there, definitely this is also affecting us. So the motor failure, two aspects. One is direct reason is the winding failure, indirect reason is the winding failure, but the direct reason comes from the voltage fluctuation on the other side and the voltage unbalance on the other side. Though EB gives an excellent voltage supply at the input, why the unbalance is coming, we'll see in the next slide. But on the winding side, on the indirect reasons, many of the motors fail due to improper lubrication, what we come across now. And it's a defective bearing, where the lubrication of the bearing and the bearing is not rightly matched to the existing motor condition. This also matters more. In some places, we have even started changing some of the ball bearings to roller type bearings so that the area of contact is increased, the heat is dissipated more on a roller bearing compared to a drive ball bearing as such. So if we come across the many of the motor rewinding that is happening in the industry now, the main contribution, let us go for the low failure. What is the failure rate which is happening on low, medium, high? You just look into the high side, the voltage fluctuation or the voltage imbalance that is happening due to the loose or the corrosive contacts, that is high, that is more in the industry. And if you see on the operation and maintenance side, the improper lubrication or the defective bearing or the misalignment, or even some of the places where the belt is given a over tension that even breaks the motor shaft or the machine shaft. So alignment is also a cause in many of the industries to lose the productivity or the lose increase in power consumption of the motor also. The mechanical looseness or the mechanical tightness, it should be optimally gripped, the motor and machine. This is where we are losing here as such. So this is the next area, the problems identifying in the existing systems. What all that is seen in the motors, in many of the industries, throughout the industries, let us say 99 of the 100 industries, we are still using the thermal overload relays, which is not able to sense the motor loading or motor overloading in case of single phasing it happens, in case of current imbalance or the voltage imbalance when it is happening. Let us say the motor is rated the full load condition, 50% loads, 57%, 75% and 100% load. In case the single phasing happening is at when the sound phases are L1 and L3 and the weak phase is L2, you find the bimetallic, on the right side you can see the bimetallic relay which we are using throughout the decades now in our motor system. It never works. The relay never operates at all and the motor may not burn also here. But the phase current in the C winding has already gone more than 110%. If see the bimetallic relays, it will never allow the motor to trip or it can never protect your motor. If it is around 57%, you can see the C winding has gone to 120%. Motor may even burn, but the bimetallic relay, the thermal overload relay may not trip as such. If it is 75%, still the line current has already exceeded the rated value, but and the C winding C has already very much overloaded. Bimetallic relay may operate, the thermal OLR may operate only, but it is not having the time to prevent the damage. At 100%, bimetallic relay the thermal OLR will definitely work, but it may not have the time to save the motor. So this is where we go by the electronic overload relays, electronic motor protection relays, which has become at the affordable cost for the given industry. Same, this is 1,500 means it's around 2,000. And definitely it is worth it trying and replacing all our thermal OLRs with electronic OLRs. And we can even think of using the OLR or the motor protection relay as a prompting device of the existing motor. What is the load? What is the normal load? What is the overload? What is the underload? You can see for the given motor, if it is underload or overload, you can have any of the relays, that is motor protective mechanisms, switchgear mechanisms working in the motor panels. It shows in case of abnormal condition only. Let us try to have a usage of this relay, motor protection relay, as a prompting tool. What is the underload for a given motor? What is the overload for a given motor? All the large scale process industries, they have gone for this alert and trip mechanism and they are using it here. But in small MSMEs, they have not tried this. Let us not go for any big amount of IoT or high costly or traditional or digital or everything. But the existing relay can be made with a underload and overload, and this can see whether the motor is operated in the right loading range. This is more important. Let us see to it that let us not have any motor burnouts in the industry. As and when the motor burnouts are there, the losses in the motor is accumulating more now. Coming to the next cause of the motor, the high no load current. High no load current because the air gap. See, once the rewinding is done, the air gap is not maintained. Definitely, it goes for high no load current. Voltage. See, a motor is rated for some of the old motors, imported motors. It is meant for 380 volts. We are giving this motor operated with our non-OLTC type transformer. Means sometimes in the night it goes to 440, 450 also. Then it goes for a higher no load current or a higher motor consumption also when the loading is less. So the areas in the motors where the high no load current is happening and the areas where this can be controlled. These are all the possible causes, and it is on not on the high current and underload also. Due to load it is happening, due to the motor condition it is happening. Both the aspects we can analyze and see to it the motor is kept in the normal loading range, and it is having a excellent protection on the overload, and is having a prompting protection on the underload as well as it. Coming to the motor means one is voltage imbalance, current imbalance. See, voltage imbalance is 4%, means current imbalance is almost 40%. Now, lubrication means we have gone for this multi-purpose greasing because it is costing 1 kg is costing 150 rupees. Maybe this is going to cost around 600 or 800 rupees, but still, yeah, polyurea thickened lithium complex grease is having a better shear resistance. At the same time, this is able to give you this life is more. See, the mean time between the greasing is, it can be even doubled. It is, so once you are doing it for a multi-purpose grease, once in 3 months or 6 months you are doing it, means this can be done for even once in a year or once in a year and above as well. And definitely the penetration length is strength of this grease is more, and this will maintain the heat dissipation excellently. It will remove the heat from the motor. I have come across an industry where it was running on a manual winding machine, where it was consuming 112 degrees on an ordinary MP3 grease put on these motor bearings. This is removed on the next day. It is changed with this polyurea thickened specialty grease. From 112 degrees, it just came down to 80 degrees within 4 to 6 hours of operation, and the motor became very steady, and the power consumption also it is saved. It is reduced. At the same time, the motor health is also improved as such. So one is on the motor, the next one is on the motor to machine transmission. The RPM measurements on the given motor to machine, what is the slip happening for the given motor and for the load. If it is a variable sport, the speed has to be optimized, because again we go by the cube root of this one. Any RPM reduction gives cube the power of power saving. So RPM reduction on a variable torque load is very much important, but on a constant torque load where all our production machines are there, you can see it by improving this, by reducing the slippage and improving the motor to machine transmission by optimizing the speed ratio of the pulleys. At the same time, optimizing the speed ratio, and the V belts are changed to cogged belts. Automatically, this improves the motor efficiency and the productivity efficiency also. So the belt drive problems, it has its own problems like poor drive, improper belt, this one, then defective drive components. More than that, improper drive maintenance and the environmental factors. These two are playing the major role. And here we find, if we are able to replace the pulley drives once in 4 years, let us say once in 40,000 hours of continuous running, this will definitely improve. A glossy pulley drive where it is looking very shiny and with no grip, this is going to be the loss, and the productivity loss is more as such. So if you see a 2 HP model, the losses on the belts is almost 15%. It is a visible loss. It is definitely measurable between the motor and machine, and it has to be corrected. That is why many of the industries have already changed over from all their existing V-belt. On the right side, you can see the existing V-belt, which is wobbulating. And on the left side, you can see the cogged belt, which is more rigid, and the power carrying capacity is 30% more. So it can have a optimized sizes of motor and machine pulley. Ultimately, the productivity is improved, the slippage is reduced. That is what we want, and the belt life almost doubles as it. This is one area which we normally suggest. This is an area always neglected by the industry. The productivity increased by almost 20%. The machine costed 10 lakhs and they wanted to replace the machine, but just by changing the pulley and belt, they are able to increase the productivity by 20% at a cost of only 10,000 rupees. This is possible in each and every industry, especially on the post-COVID crisis. Next, let us move on to the main agenda of our this one webinar. Compressors and the compressed air system, both are complementary. Everyone thinks, either the OEM or the user thinks compressor is more important, but not the compressed air. Let us go into it. What is the receiver temperature? What is the auto drain valve functioning? What is the compressor loading and unloading? What is the load and unload hours? The refrigerator dryers in and out temperature, how does it matter to us? Pressure drops happening in the system at the incoming to the tail end. What is the changes? What is the compressor nameplate says? What is the package power consumption? What is the watt per CFM? compressor, on the generation side, there is a scope for savings. On the distribution side, there is a scope for saving, and on the usage side. All the three areas, if you are able to attack, and definitely we can see a savings of almost 30 to 50% in your existing compressed air consumption as such. If you find in the last line, the annual calibration of the pressure sensors, this is, I have not heard in any of the industries, having visited more than thousands of industries, not only for audit, but for energy assessment, other aspects. None of the industry, they do the annual calibration of the pressure sensor, which is a pressure control sensor in the compressor, which is used. That needs to be annually calibrated to know whether the sensor is giving the right, say a 0 to 10 bar sensor is normally supposed to use on a compressed air, especially on the utilities. We are using a 0 to 16 bar sensor, which the accuracy is getting lost and the resolution is getting lost. And year after year, the calibration also matters for this compressor utility maintenance as such. If you find the compressor is losing more, not only on the mechanical side, the heat of compression. This is where almost 80% is the loss happening. So the heat of compression is seen throughout the compressor house and how the compressor house is maintained. Then comes the useful output, which is around 15%, and there also 50% is getting lost at the load end as such. If you see, this is a case study we have done in LS Mills at Teni. They have maintained an excellent study. They have done it totally digitally. All the flow rates, everything is digitalized. What is the velocity of the compressed air? What is the CFM? And at the same time, what is it there before the dryer, after the dryer, and after the receiver? Everything is monitored. I don't say we have to go for such a sophisticated, costly system, but definitely pressure differential gauges across the dryers, it will definitely show the dryer is the culprit to have a more of pressure drop, and what is the loss in the existing dryers, especially the refrigeration dryers. This is a economical way of doing it. Across the dryers or across the filters, whatever that is there in the filters, the coalescent filters or the water separation filters, it is showing this red and green gauge. It is not a correct indication what we have come to understand from the field. Instead of that, let us have two gauges on the incoming side and outgoing side. We can definitely monitor the pressures to know what is the pressure differential across the gauges, across the filter when it comes, and how much it is allowed, what is the minimum, how much it is allowed, and what is the maximum that is to be kept as such. So the daily checks, thanks to the LG compressors, the daily checks to be monitored in the existing compressed air system. One is the hour meter reading on the loading hours and unload hours. Then is the discharge temperature of the compressor, what is seen at the air receiver. See, what is the post air cooler is working and how the post air cooler is working, that can be seen by the air receiver's temperature. Load and unload pressures, whether we have optimized. Then this air filter clog indicator. This is a very gray area. Many of the compressor OEMs have to give a serious thought about it, especially in Indian conditions, where the SPM or the suspended particulate matter in the air is very much more, the dust is more, and the clogging is more. Definitely all the OEMs, compressor OEMs have to give a serious thought and see to it that the air filter clogging is not allowed in the existing compressor and it is monitored. Next comes the hot air exhaust from the compressor. What is kept as a chute or it's a chimney. This chimney type of exhaust, it is a heavy loss to the compressor house as such compressors, and compressor house temperature goes by more than 5 to 10 degrees. And also, if you see the expanded size, let us say it is a 2 feet by 2 feet is the size that is kept open at the top. Minimum it should be 50%, 3 feet by 3, 50% the size should be more. It should be expanded, and the size or the length of the expanded duct should be so less, it has to exhaust the heat very easily and effortlessly. Then only the compressor house will be at ambient temperature and compressor also will be healthy. I can suggest you, having done energy audits, we have suggested to many of the industries to expand the duct and do it, or if it is not possible, we have just suggested them just have a 2 meter of duct, just put on the compressors. Automatically the hot air that is there, it is just going to the top only, it is not coming back and it is not being sucked back to the suction. So economical type of energy conservation measures are also very much there, and this has been implemented in Tyagaraja textile mills at Madurai as such. Then comes the refrigerator dryer, where the inlet and outlet temperature is around the ambient. Ambient is around say 35 degrees, means the outlet temperature is around, the compressor delivery temperature is around 38 after the post air cooler. and after the dryer, it should be around 32. This temperature monitoring is definitely needed now, especially for a refrigeration dryers. You can have in situ temperature gauges on the inlet and outlet. You don't need to monitor by infrared thermal imager each and every time. You can have in situ gauges, fix it on the inlet and outlet lines. This will show the dryer is working healthy or not. Not only on the dryer, if you see the air receiver, what is the ambient temperature is around 35, but the air receiver temperature is showing 44. It means that the post air cooler is not working. The compressor is pumping a hotter air outside, so automatically the CFM goes down. When there is a cool dry air at the inlet only, you will get a cool, at least a dry air at the outlet. The dry air is coming very hot at the inlet, means the dry air at the outlet will be very much hotter as such. So monitoring the air receiver's temperature has become mandatory now in many of the industries. This is an add-on temperature gauge with an indication and what is to be the normal temperature, what is high temperature. This can be had on the temperature gauge assets, and you can give a remote indication also, audio visual alarm. And on the receiver, the same thing. What is at the ambient and what is the plus or minus 5 degrees is the inlet to outlet is the temperature difference that is happening on the refrigerator dryer. One of the possible symptoms, healthy symptoms that can be seen on a refrigerator dryer and on the receiver to show the compressor is working healthily well as such. Thermography, in fact, many of the industries throughout the world, they are using only on the electrical side because it's a non-contact, that is a plastic, means it is a all the switch gears which is not metallic, definitely the emissivity is not a problem there. Everywhere on the electrical side, the thermal imager is used, but let us try to use the thermal imager on the process side. You can see the temperature gradient of the process. You can see the process flow times in the production as well as in the utility. Thermal imager is an excellent, affordable and non-invasive tool to be used in each and every industry. Each and every industry should mandatorily have this thermal imager to see all the energy flows on the production and the utility side. And micro level monitoring is done by the low level people, and macro level analysis, MLM and MLA, both are wanted in the industry. The macro level analysis is definitely will pave a way how the utility equipments are operated within their healthy ranges as such. You can see it is not only on the process pipings on the water, but it's on the air also. Piping plays a major role to see to it that the compressor has generated 1000 CF, means it has to be transported to the process, means it should be smooth. You cannot have any T junctions on all your compressor house. Any of the T junction is a point of turbulence, it's a loss to us. Let us see the thermal image of this. We can see on the vertical side, one compressor is giving the delivery, and on the horizontal side, where you can see the cursor, this compressor is giving the delivery. So both the deliveries are having a clash and the turbulence of air is happening. Definitely, you can see the T junction is a loss to the compressor house as well as to the compressed air system as such. This has to be definitely be changed to conjoining belts. I will just show the how the bends or the junctions are done. We can see imported this one image where it shows what are all the T junctions that is there in the compressor house. It is a point of turbulence, and where the fluctuations in air pressure is more, and it's a cause of a loss, energy loss to the compressed air system. What are the do's and don'ts? As a traffic rule, it should be a slow in and fast out. So any of the T junctions will never work on the compressed air house or in the system, or any of the process trains on the water line also as well. It has to be a conjoining bend or a 45 degrees directional conjoining air lines we call, or it can be on pipings. This is like that, and no sharp bends is allowed. Longer bends will definitely reduce the friction loss by around 70%. It is able to reduce. So for a given compressor, 160 kilowatt is the compressor, almost 1000 CFM it is giving a production, it is giving a delivery. Every week it is giving almost 1000 liters of water. 1000 liters of water is produced in a compressor, means whether it is removed correctly. Whether it is removed at the compressor house, almost 68% is removed at the post air cooler. So the post air cooler and the compressor hood, it should work definitely. If it is not efficiently working, definitely you need to have a post air cooler on the outlet of the compressor, because many of the auto drain valves within the compressor hood, where we have gone for energy audits, everywhere it is just bypassed only. So how will the post air cooler will work when the water is not being pumped out through the auto drain? So definitely almost 68% the post air cooler is supposed to function, and 23% it has to be cooled by the pipelines, especially on the receivers. It has to get cooled by the receiver, and receiver is auto drained out through the level sensing drain valves. Then only it is cooled in the getting cooled, and the water is removed. 54 liters, 5% is removed on the pipelines up to the tail end process. We can see for a given ambient of 30 degrees at 50 degrees RH, at 50% RH or 80% RH or 100% RH, we can see the kg of water is from 27, it has gone to 68. So the water, that is water vapor per hour for every 1000 meter cube per minute, the increase in rate is very much high, especially when the relative humidity of your ambient across the compressor, surrounding the compressor, is a critical input. This needs to be also monitored so that water ingress is not there in your compressed air line. So the three stages of water removal, one is on the post air cooler within the compressor hood. If it is not functioning, you try to have a post air cooler. It is definitely cost effective. Second stage is through the receiver, where definitely it is expensive to a heavy volume. Definitely by the Boyle's law, definitely P1 is equal to P2 VT, we say. So once increase in volume, the pressure drops, and definitely the water also getting accumulated at the bottom and automatically functions out. This I am just telling you for an instant only. It is not accumulated, this one. Next is the third stage, where the refrigerator dryer, the existing air is cooled down and the water is being sucked out of the refrigerator dryer, from the refrigerator dryer. So all the three stages has to work in the existing compressed air system, especially in the compressor house. This one only will definitely see to it that the compressor is healthy and the compressed air is healthy. You can see almost quarter of the compressor air receiver, it is filled with water. In this type of air receivers, you can see in many of your air receivers, almost you leave it for a day, almost quarter of your receiver is full, and this is going to cause a lot of malfunction all your pneumatic systems at the tail end. Why the moisture separator like this, what you are using on the steam side, this is used on the compressor side also. This is to be removed, and the water to be removed on the compressor delivery side from the air end. So the water separator that is there at the separator at the compressor delivery, that also needs to have the auto drain, and this auto drain has to be functioning along with the receiver's valve, because water separator definitely it's like a baffle plate, where the compressor with the velocity is hitting the baffle plate, and a lot of water is collected on the water separator. And many of the industries, water separator is another neglected area in the compressor house, where lot of water is collected and it is not released at all. Only the air receiver can release, and that too the manually by the operator. Once in a day he comes and releases the water. He is releasing this water only by manual means, not by automatic level sensing, electronic level sensing drain valves we don't have in the system. These are all the areas. Automation definitely paves a way to improve the compressed air health. Next comes the gray area, where throughout India or throughout the world, this is happening. This I just come across in many of our energy audits. We are measuring around less than 1% of the Pascal we are seeing on the air intake filter. This is from one OEM and this is from the next OEM. See, you see the compressed air intake filter, the differential is around 600 Pascal. If it is mentioned as 600 Pascal, definitely the user will take an immediate step and he will correct it. If it is just like that, he sees it's only 0006 bar, means he ignores it. So 1 bar in 1 lakh Pascal, almost it is in bar, it is mentioned in bar. 1 bar is equal to 1 lakh Pascal means it is less than 1%, it is not readable. So once it is not readable, it is not correctable and it is left like that, and the air intake filter gets choked immediately as such. So we can have a Magnahalic type of gauge on the air intake to monitor the what is the Pascal that is to be minimum kept, and every day it can be cleaned. In some of the compressors, especially the screw compressors, they have fixed this screw type vacuum band indicator, which always shows positive side only, and it will never show the compressor that is air intake filter is choked or not. It will show always healthy. So this is the area where the OEMs can pitch in and definitely give a compressed air intake to be monitored and to be corrected. How this can be corrected? There are two ways. See, as I was telling before, India is a condition where the heterogeneous air and the temperature and the RH, this is mattering more of us to us. So let us have three stages of air intake filtration. Like it's a V-type SS filter, which is like an Atlan. This one, it measures it just avoids the dust that is happening in the macro level. Up to 10 micron, you can have the filter, which is washable and cleanable, online cleanable daily or weekly. And the existing paper filter, you don't allow the existing paper filter that is there inside the compressor hood to get choked first. You let these two stages. The one is the V-type filter, the other one is the polyurea. This one, it's a nylon filter which is kept on the black. You can see on the right side image. These two can definitely filter out the bigger size micro this one dust, and it will allow only the pure air inside the main air filter. So by this way, you are not allowing the main air filter on the existing air intake to get choked very frequently. You can allow it, and you can keep the minimum level of choke within the system by daily cleaning it and weekly cleaning it by online cleaning as such. So investing on passive receivers on the dry side and the wet side, these two are more important now. Every compressor OEM says it is enough if we have one receiver, but it's not enough to have one receiver. We are now definitely supposed to have two receivers. One is a wet receiver, other one is a dry receiver. Definitely, the wet receiver will take care of the compressed air pulsations. The dry receiver will take care of the process air pulsations, and definitely it will work in sync. It will work in tandem and see to it that the compressed air is always kept steady at a steady flow and pressure. Again, coming back to the compressed air hood, you can see the typical pressure sensing point, which is just taken at the elbow point of the oil reservoir. This is a point of turbulence. All the Indian imported, all the compressors OEMs can definitely think over it and definitely see to it that it is kept in a pipeline on the line that is going at the delivery, where you have a streamlined airflow, streamlined pressure, and there is no pulsation in the pressure. Definitely, this will pay a way. This will definitely reduce the energy consumption of the given compressor. The wild fluctuation of compressor kilowatt will not be there because the pressure sensing is also taken from a steady plane as such. You have seen many of the areas where we have done the energy audit. We could find this type of fluctuations, especially happening in the compressors. It's a cyclic fluctuation happening once in, that is 3 times a minute. It is happening from 50 kilowatt to 90 kilowatt. You can see what is the acid test which is given to your electrical distribution system because of this, and how the compressor is performing. Compressor's health also deteriorates very badly if it is fluctuating like this. The reason is it is a very choked air intake filter. Next one is the pressure control sensor. It is taken from the compressor hood and it is put on the receiver. The third one is for the cleaning application. They had some 4 types of cleaning guns, but they did not have the cleaning receiver, air receiver dedicated for the cleaning application. After doing all the 3 modifications, they could find all these fluctuations. Definitely, it has dropped to almost this one, and it was consuming almost 5,500 units per day. A battery of compressors, it came down by 5,000 units. 500 units was the savings that was achievable from these wild fluctuations to a steady compressed air kilowatt input consumption and a steady pressure also at the output as such. It is not due to the process this has happened. This has it has artificially happened in the compressor house, and due to the there is no provision for a clean air receiver, and the air intake filter also getting choked. That is on the compressor side. Let us just have a few slides on each and every utilities where the scope for saving by condition monitoring is there. It is a typical pump we are using in hundreds of pumps we are using in our utility industries, where we find what is the optimized discharge pressure which you are supposed to have for the process. Are we maintaining it? Let us say I am having a head range of 18 to 29 meters, almost 1.8 kg to 2.9 kgs. I am supposed to have a LPS of 11 LPS at 1.8 kg, and this we wanted to see whether we are optimizing the pressure for the given pump and the system. What does the process need and what is the system pressure pump is giving? This needs to be monitored as such. For monitoring, again, everyone thinks pressure gauge monitoring means it is a very easy task, just to have a nipple and then just to screw in the pressure gauge. It is not like that. You are supposed to have, because having worked in refineries for many years, we come across there are all instrumentation installation standards. Yeah, pressure gauge, ordinary pressure gauge also needs a block and bleed valve, because this block and bleed valve is a inter mechanism. It's a this one which shows every number and then every month you can just block the process and see for the zero of the gauge whether the pressure gauge is giving a zero, either the zero is okay or the range is okay. This can be checked. So any of the pressure gauges in your system on the utility or in the process, you are supposed to have this block and bleed valve. It is a point to have as a standard, as such piping standard. Then pressure gauge, what is the green band, what is the yellow band, what is the red band? You have the IoT based system to have what is the low pressure to be set, what is the high pressure to be set on your gauge, and give a remote alarm and see that your pressure in the system is optimized and you are operating at the same pressure, optimized pressure. Leave alone the pressure in the pumping system. Pumping system has, one is the loss that is happening in the pumping system, the other loss is happening in the pipings. Almost you can see 70%, the pipe efficiency is only 70% at a 30% efficiency of the pumping system. If the pumping system efficiency has been increased to 70%, definitely the improved piping, from 70% it has gone to 90%. See, piping is an area, the Indian agriculture has understood that, but the industry has not definitely understood. We have to go for this GI pipe or this MSER diode pipe, especially on the water line pumping, to go for this rigid PVC pipings. Yeah, VFD on the incoming of the pump, definitely it is able to avoid or remove the throttling side on the delivery side. Yeah, throttling valve or a damper on the delivery side, it is a loss to the system. Instead of that, a VFD will do a better job with a lesser kilowatt consumption. Leave alone the pipings, the tubings also matters more, especially on the machine side. A lot of machine panels having the tubings. Instead of having these sharp bends and sharp elbows, we can have this type of tubings. Almost you can see so much of the flow is streamlined from the point of generation to the point of usage. The enhanced plant efficiency is happening not only on the main piping like 4-inch pipe or 6-inch pipe, it can happen in even on your 1-inch pipe or in a half-inch pipe also. You are having a 4-inch pipe, you are having a 4-inch pump, let us say the delivery and the suction, at least those fittings has to be changed at the time of post-COVID crisis, at the post-COVID startup operations. These are all the areas where the choke is more in the system that has to be removed, because after all the velocities at the suction and delivery, it should be generally lower than the entry and the exit. That has to be maintained. Instead of a 4-inch pipe line we are having on the pump delivery, by a few years, it becomes 3-inch, means definitely the friction increases by 3 times. So this is a loss, and definitely the kilowatt consumption also increases. Any of the sharp bends used in the pipings, 70% friction is increased more. Friction loss is more as such. So rigid PVC pipes on the suction and delivery, definitely the KWH savings, you can see a straight away 20% savings. Coming to the compressors, on the this is on the air utility side, air compressor side. This is on the chiller side, on the air conditioning side. On the compressors and on the auxiliaries, you find auxiliaries consuming 50% on the supply and return fans only. The exhaust fans around 52 and the exhaust fans around 30%. All the other pumps, the consumption is as such less only. So we have to go for a 3-tier approach, especially on the air conditioning approach, especially in your buildings. One is the heat avoidance, that is the first tier, like avoidance of the heat on the solar heat and the solar load, heat load. The avoidance of heat is one thing. The passive cooling, like the glazed tiles or the glazed windows and other things, like passive cooling. And then only we go for concentrate on the typical air conditioning or the chilled water system, where the kilowatt per ton is more matter to us as such. It has almost from 0.5 to 0.7 kilowatt per ton it has come to. Instead of 1 to 1.5, it has come to almost 0.5 to 0.7, thanks to the 3 tier of cooling as such, 3 tier of cooling strategies employed in all the building establishments. If you see the Paretto Principle, 20% power consumers, they are the fans and pumps. They cause the reason for 80% major power consumption of the AC compressors, especially on a dirty condenser or a dirty evaporator. For a given evaporation temperature of 7 degrees at the chilled water, you can see the rise in refrigeration capacity from you can see around 0.7 to it has gone to almost 1 kilowatt per ton. almost 30% increase. So the condensers and the evaporators, the more they are dry, it is going to be a loss to the system. Poor maintenance is a reason, it's a visible loss. So on the air conditioning side, if it is on the generation side, it's a low cost, very high cost, especially on the generation if you are replacing the compressors or the compressor internals. But if it is on the transmission and distribution of the chilled air, that is the air conditioned air, it is a zero cost to low cost only. If it is on the usage side, again it's a zero cost to low cost, where you are able to reduce your settings and match your air changes and the air circulation in such a way that you have the indoor comfort, indoor air quality is maintained, at the same time you have the fresh air provision is there in the building. And definitely three areas to be attacked to see on the usage side, on the distribution side, and on the generation side. On the generation side, especially on the Freon circuits, where we are maintaining and how we are maintaining. If you are having a Freon refrigerant charge, it has over a period of time, over a year, it has leaked out, it has become low on the low side and high side, and the duct temperature is formed, means it is the cause. The see, you need to have the temperature, the Freon gauges on each and every side of your, even your ducted tunnels, all your package tunnels you will have, but all your ducted tunnels, all your smaller size ACs also, you can fix these gauges to know whether the Freon pressures are okay, you are maintaining correctly, or we are maintaining more. By any chance, if you are overcharging, means the consumption is also going more, and again the duct temperature is warm, again the overcharge. These are all the areas, or the overcharging is done, or air in the system, especially on the refrigeration line. This also can cause the malfunction of the air conditioning, especially on the Freon side. Then comes the internals of the, like the expansion wall or the orifice tube getting choked or plugged as such. So the charging capacity or the charging parameter or the suction parameter is a more critical parameter to be monitored in any of your air conditioners, right from 3 tonner to say 100 tonners or more than that also. Above higher size tonners, every HVAC OEMs as well as the users, they are monitoring it. Especially less than 10 tonners, it is not monitored. Let us monitor it. Instead of, we see normally we have a suction pressure setting of 35 psi to trip and a delivery of 350 psi to trip on the on a R22. I am just telling you on a case study. But normally the pressure is around 70 psi. You can have a pressure gauge to have an alarm. If it is going less than 50, you can give you alarm. If it is going more than 280 psi at the delivery of the this one condenser, you can have an alarm. See, these are all the areas the alarms will prompt the user to correct before itself, not allowing the Freon to escape out or Freon to choke the condenser and give the problem. The more it is charged, overcharged also, the efficiency drops to more than 80%, 85%. It is undercharged, it is leaked out, 70%, the efficiency, the drop in efficiency is almost 30%. So Freon pressure monitoring is a very critical this one, especially on all the air conditioners. It can even happen to all the any of the split or the package ACs or the ducted split ACs as well as this area. It is put on the open terrace. Everyone ignores it. Let us try to have what I was telling you, a 3-tier system. Let us have a V-type filter. Let us have a 10 micron filter. Then we can hope for this HEPA filter. Definitely this type of abnormal deviation, especially totally choking of this filter, especially on the pressure, this will not happen. The indoor air quality of a given premises by this pressure filter, it is totally dropped. This can be corrected as it. Blowers, all your existing blowers, air handling units, they are delivering only 30 to 40% efficient. At 30 to 40% only output is coming because of the efficiency drop. This can be definitely improved upon. As our Murugesan sir was telling, it will be developed separately on a detailed blower session as such. Coming to the gensets, whether we are, see, some of the gensets are used, whether we are using the inputs to the genset as air, diesel and the diesel, everything is correctly used. The losses happening on the water and exhaust circuits and the output which is monitored. Here you find why I was telling on this first slide, where on the transformer side, on the electrical distribution side, why you are supposed to keep around the power factor of 0.95 to 0.96 for a stable function. Acceptable steady state of operating function region is for a genset is from almost from 1 to say 0.8. You can have the mid region for a stable operation. Unstable region on the leading side, it's a cost loss to the generator, and on the lagging side, less than 0.8 also is a loss to the generator. The alternator definitely gets overheated. So let us try to operate around 0.95 for the genset as well as for us the from the EB side also, by having the loaded compensation for all the machines. You try to maintain around 0.9 power factor. A cool dryer to the genset. Again, what has been told in the compressor, genset also, you can see the genset with this air intake filter. It is a totally choked filter, and this generator is running for more than 12 hours a day. With the output is totally staggered and the output is totally fluctuating because the choked air intake filter was there at the genset. It can be corrected by a micro V-type filter on a two-stage filtration. This is an area you are using a thermal imager. As I was telling you, referring you before, on the process side, try to use your thermal imager. The generator got derated because at the delivery end, when the generator was running on the case study, we found this bend where it was showing 270 degrees, it was totally choked and the back pressure was more. It is not monitored. Once we noticed this, we told the industry, they removed the L bend and they have put a T connection, and they kept an inspection point and they removed the choke in that line. The generator came back to the full capacity. So a generator's capacity can be restored if the diesel input is maintained at 38 degrees, where the centi-stokes or the viscosity value of the diesel is excellent. First point. Second point is the back pressure is not there in the genset. And the third point is the poor PF conditions that is in the load, that is corrected and load and compensation is done. Definitely the generator can be, the capacity can be enhanced to 10 to 20% by all these factors. The possible faults that is happening in the genset can be corrected upon. Why the genset has to be kept on top on the open terrace, where it needs all round air at the surroundings. If it is not there, and even at here also you find a mistake where at the delivery end or the exhaust end, you don't need to put a L bend there. You can just have a rain cap so that the air has to, the exhaust has to come out slowly and steadily, brown and hazy brown yellow color. It has to come as exhaust. That will come very smoothly and steadily, and it will not cause any back pressure in the genset. Coming to the boilers, a list of losses are there. More than 10 to 12 losses are there. Apart from the losses on the feed water tank, on the radiation, this one on the piping, then on the boiler loss, radiation loss, on the low flash steam loss, on the high HP steam loss, the flue gas automation and the moisture in the fuel. These are all the areas it can be definitely seen as such. Steam dryness has to be kept more than 95%. That is the dryness, the moisture percentage in steam, it should be less than 5%. The moisture separator to be installed at the boiler, at the load end and at the headers, to see to it that the steam is always kept dry and it is not having moisture more than 5%. You can see, thanks to Forbes Marshall, you can see what is the 100% steam at 120 degrees and the air in steam. If you see the air is not removed from the moisture, from the steam delivery, the air vent is not functioning at the moisture separator, this will happen and the temperature drops and the heat transfer efficiency of the steam also drops as such. So putting a moisture separator at the steam at the boiler end, definitely 10% savings is there. Not only the 10% savings, the productivity time came down from 18 hours to 14 hours. Almost from, it's a less than 1 ton boiler, from 50 liters per hour, it has come down to 45 liters per hour. 10% savings is there. So the safety is more important as a OEM things, but what is more important is cost of insulation, heat loss of savings, and economical thickness of insulation. Safety has to be undercover only to achieve the energy conservation and energy savings. It need not overtake this one. Let us, on a 2-inch pipeline, you cannot put a 2-inch line or a 3-inch insulation. As a over safety, I am trying to improve upon this one insulation. The lesser the insulation size, it is better for the economic thickness of insulation matters. This is not for the insulation. What the genset is operated now by many of the industries now is we are operating the genset at only 50%, 60% only, because we are operating at 80% loading as told by the OEM. We are operating the genset at 0.8 power factor only. 0.8 into 0.8, almost 60% loading only we are giving to the genset. But the genset can be given by almost 10 to 20% more at a enhanced. It can be enhanced. The capacity can be enhanced. At the same time, the units per liter can be definitely improved by almost some 10 to 20% can be improved upon. So in any energy equipment, any energy management, buying an energy equipment is only hard done. How we are going to run the equipment, whether you are running it efficiently or right from the installation where there are losses, that has to be addressed to. Whenever the safety fails, conservation fails, and the pollution starts, we all are aware. We see here that we are trying to have the prompters in the equipments, in the utility equipments, to see where the problems are identified and getting corrected. Thank you all. Thank you all for giving a patient hearing and giving an excellent opportunity for giving this presentation. Thank you all.
Thank you, sir. That was a very extensive and a deep dive into the energy optimization measures, and especially on the topic that we discussed, as well as a special focus on the compressors. I think it was really fantastic to hear you explain all of those. We will now move on to the question and answer session, and I would request members to kindly use raise hand option, and I will call out your name so that you can ask your question. I can see a couple of hands raised. I would request Mr. Selvan, go ahead.